Hi there, this is Jacob Nash Algebra Lessons, and this is Unit 0, Lesson 4, on simplifying radicals. So this is, once again, a review. This is something you already should have learned if you're in Precalculus. And you might remember it and that you didn't like it, and in my opinion, I don't really like it that much. But it's just something you have to do. So, before we get started, some perfect radicals that you don't necessarily have to know, but they're useful to know when you're simplifying them. You have your squares, your cubes, your fourths, and your fifths. And the higher the exponent, the less you really would be able to memorize because, like, look, just 3 to the fifth already equals a 4-digit number. So, they get crazy. So those are some good ones to know. Hopefully, you would, of these listed, you would know that and that already, and maybe those. Those are common ones that you know, but that's okay if you don't. But they're just useful to know, and you can't always use your calculator in Precalculus. Only combine radicals with the same radicand, so number into radicals. So for example, if you had something like this, do not do this. That's not something you can do because you can only do that if this is the same number. Or if you did 10 to the 5, whatever you would do. Or not 10 to the 5. 10 root 5. That's just like those you treat these like variables. So if you had 5x, oh great. This thing is so stupid sometimes. Oh, I went on the wrong thing. Okay, so if you had 5x plus 5y, you wouldn't do 10xy. You can't do that. Or whatever you would do if you tried to do that. But you can't do that because they have to be the same. So keep that in mind. Also, radicals cannot be on the denominator. Well, why, you might ask? For no reason, actually. It's just something stupid that someone came up with one time, but you still have to do it. Sorry about that. You just heard that noise. There's this dumb bug. Alright, so let's do this one first. I have the answer written there for this one. So we already know what the answer is going to be, but let's just see how we would do it. So, 45 plus 125 square roots of those. How do you do that? Can you just add 125 plus 45? No. Why? Because that's like x plus y. You can't do that. You have to make them the same. Or you have to make we just need to simplify these first. So what you do is you figure out two numbers that multiply to equal this number, and one of them you can take the square root of. And the bigger the number, the better. There might sometimes only be one that you can do anyways. But if you do one that's too small, like if you had 48 and you did just 4, you might be able to do more than that. Because you could do a 16, for example. So for the 45, you can do 9 times 5. What you can just basically do is write a list of your perfect squares, and just by these, can you do these numbers go into 45? Does 25? No. Does 16? No. Does 9? Yes. Does 4? No. So that's why we're doing 9 times 5. So you can take the square root of 9, and that would give you 3, and you still have a root 5 in there. For 125, might be a little bit harder to tell, but let's see. 4, 9, 16, 25, 36. Let's just say that probably would be all there is. So, you might be able to use your calculator, you might not. But, you might not know off the top of your head if these go into there. But what you can do is think, you can try to think ahead. Why would they give you this problem if you couldn't combine the two parts of the expression? So that must mean that you're gonna end up with a root 5 in there. So you pretty much want to figure out what 125 divided by 5 is. And that's 25. So 25 times 5 is what we can use. So 25 does go into there. If that just confused you, that's okay. But that's what I would do. You think ahead and think. They wouldn't give you this problem if you couldn't combine them. So, of course, there would be a 5 left over in that one, too. So the square root of 25 is 5. You have a root 5 still in there. Now you can combine them, and you add 3 plus 5, 8. You don't do anything with the root, 5. And that's what your answer is, see? So, that's how you do that. Now we're looking at the next one. Alright, number 2. We need to simplify this because, for some reason, you're not allowed to have a square root. So we need to think about how we can cancel out that square root. You might have learned just to do this, but if you're like me, you want to know why that works. Well, remember how you can make this into exponential form? In exponential form, this would be 7 to the 1/2. And if there is no square root, then you would get 7 to the 1st. How can we make it 7 to the 1st? If we have another 7 to the 1/2, when you multiply them, because you add the exponents, then you get 7 to the 2/2, which is still just 7. So that's how that works. So you multiply this, you just multiply it to where that the root symbol will cancel out. But you have to do the same thing to the numerator also. So you would get 5 root 7 on the top and 7 on the bottom, and that's actually just your answer. Alright? This isn't 5 times the square root of 1/2. Sorry that 5 is so big, it should really be smaller. Can I erase that? Yeah, I can. Make that smaller so that you don't think that. Alright, here it's easier to just change this to the 5th root of 1 and then the 5th root of 2. 5th root of 1 is 1. Anything root of 1 is 1. Now, here we have the 5th root of 2. And now it's not as easy to just multiply by the some sort of root. So what we should do is change this to exponential form. That would be 2 to the 1/5. And we want this to get to 2 to the 5/5, because that would make there be no more root. And to do that, we would multiply it by 2 to the 4/5, because you add the exponents. 1/5 plus 4/5 is 5/5, so that leaves us with 2. And you do the same thing to the numerator. So that gives us 2 to the 4/5 on the top and 2 on the bottom. Probably want to make that in radical form though, so 2 to the 4th, or 5th root of 2 to the 4th over 2. You can simplify that further. 2 to the 4th is 16. And you can't do anything with the 5th root of 16 over 2. That's your answer. Alright, now this one. This one's a little bit harder, but you use a conjugate with binomials in the denominator. I don't really like this one, but of course you still have to do it because there's a root in the denominator. So what do? Okay, well, the conjugate is what we use. And so what we always do is we multiply by the same thing, except for there's a minus. You change the sign. So that's a plus, so you make it a minus. And you do the same thing on the top. But this time you have to do some order of operations. So on the top, you distribute that 10, you would get 50 minus 10 root 3. On the bottom, you have to use the FOIL method. You always know that there's actually only going to be a binomial on the bottom. Or not even a binomial. There's only going to be numbers. Because the point of doing this is so that the roots cancel out. So really all you have to do is multiply the first two which is 25. And then the last two, which are root 3 times root 3 is root 9. Square root of 9 is 3. But it would be 9 minus 3 because of the signs. But if you really wanted to see how that worked, the full thing, that's just a shortcut. So 25 for the first, the outer 5 root 3, the inner 5 root 3, the last minus square root of 9, and these cancel out, as I said, and this was root 3, square root of 9 is 3, 29, or 25 minus 3. So really, the steps is that you just multiply these, then you multiply these, and make sure you have the right sign. But you usually would get not roots. Well, yeah, of course you wouldn't, because that's why we did that. You won't get roots. So 25 minus 3 is 22. Then we have 50 minus 10 root 3. Are we done? Not quite yet, because we see our three numbers that we can combine these because they're the coefficients, or not really coefficients, but they're not under a root. We can't do anything about the 3. But 50, 10, and 22 all can be divided by 2. So we change that to 25 minus 5 root 3 over 11. And that is your answer. So, hopefully that was a good review. If you need more review or help, there's a video specifically on that, on Jacob Nash algebra lessons. You can just look at simplifying radicals, and that's JNAL. Feel free to ask any questions in the comments if needed, but also you might want to just look at other videos if this didn't make sense to you, but hopefully it did. And that is the end of our algebra review unit. So then we'll actually get into new stuff. So these 4 things, these lessons, were things that you needed to know. So remember these things so that the rest of Precalculus isn't as hard. Thank you for watching, and that'll be it.